Alright guys, so now we are going to talk about the section 5.4. We are almost at the end of the semester. Logarithm functions. A logarithmic function is any function looking like f of x equal log base a of x. Okay? Always think about the base. You need to talk about the base. Remind yourself in which base you are working on. You are working if you have f of x equal log of x, by example, that implies that we are working in a log base 10 of x. Okay? No, nothing right here mean you are working in a log base 10. So now let's work on the example number 1 and try to graph and find the domain. Even though you should know that the domain for the function is defined on the x-axis, you will be able to find out what is the domain by just looking at the graph that you will graph with your calculator. So if we're trying to graph the function f of x equal log base 4 of x plus 2, log base 4 of x plus 2. What's going to happen, and I think it's nice for you to try to change your base. Like this, you will be able to graph and find the domain of your function in a much easier way. And most of the time, the base we want to work with is the base 10. So if I'm looking at the change base formula, one of the logarithm property you have studied in the previous session, the log base 4 of x plus 2 is equal to log base 10 of x plus 2 divided by log base 10 of 4. So your function f of x, which was equal to log base 4 of x plus 2, is now equal in log base 10 of x plus 2 divided by, let me rewrite that in a better way. So I'm going to rewrite this in red or in blue. You know what? Just to log base 10 of x plus 2 divided by log base 10 of 4. And if we want to find the domain of f of x, what we want to do is focus on the fact that the log base 10 of x plus 2, x plus 2 has to be greater than 0. We know that for a fact. I would like to remind you that we just said that x has to be greater than 0. So in that case, x plus 2 has to be greater than 0. X plus 2 has to be greater than 0. And if I solve that inequality, that means x has to be greater than negative 2. I would like to remind you, reviewing for the final, I subtract by negative 2. This is why I end up to have x greater than negative 2. And why do I have greater? Because when I'm subtracting or adding, okay, or multiplying by a positive number, in that case, subtracting, I don't flip my symbol. The only time I'm supposed to flip my symbol is when I multiply or divide by a negative number. Okay? And that says that the interval notation, if I represent my number line, that is my 0. So if I plot my negative 2, which is on the left of my 0, x is greater, so I need to go toward to the right. And because there is no equal, I'm supposed to have negative 2 plus infinity in between parentheses. A parenthesis next to negative 2 because no equal. Okay, there is no equal on my symbol. And there is always a parenthesis next to plus infinity. Now, if you look at the graph, you can see that from negative 2 right here to plus infinity in that direction, you have the domain. All right? Now, if the question was find the range, when the range is all real numbers, That's pretty easy to remember when we try to study a logarithmic function. The range is all real numbers because it's going from minus infinity right here to plus infinity right there. You might think that the graphic right here is just stopping, but it continue to negative infinity right there, and it continue in the direction where it going to plus infinity. Okay? Now let's jump on the second part of this logarithmic function, and let's try to represent the and graph the function regarding the example number 1. So for that, what I'm going to do is pretty much doing the same thing. First of all, I would like to remind you that a normal log, all right, a normal log, it corresponds to a log base e. So my function f of x right now, is supposed to be equal to a log base e of x plus 2. Now, if I want to find a domain, what I'm going to do is I'm going to change my base, and using my change base formula, I'm going to try to be in a base 10, which is a log. No need to write 10. When there is nothing, it's a log. And log of x plus 2 divided by log base 10 of e. And that helped me to define that if I have to have x plus 2 greater than 0, I'm going to have x greater than negative 2. And that implies, again, that from negative 2, going to the right, going to the right because x is greater to plus infinity, there is no equal in my symbol, so I'm going to use a parenthesis, and my interval notation is going to be negative 2 plus infinity. Okay? I'll let you graph the function with your calculator, but you should have a domain going from negative 2 to plus infinity. We can do exactly the same thing for the second graph. What do we have is f of x equal log base 2 of x minus 1. Using my rule of my logarithm property, I'm going to change base, and I'm going to put myself in a base 10, which is going to be log of x minus 1 divided by log of 2. That implies x minus 1 has to be greater than 0, so x has to be greater than 1. And if I represent my number line with my 0 right here, 1 will be on the right. Because x is greater, I'm going to go from 1 to plus infinity. There is no equal in my symbol, so I'm going to use a parenthesis, and my domain is going to be 1 plus infinity, with parentheses always next to infinity, and we know why. There is a parenthesis next to the 1 right here. Alright, so now let's try to graph one of the two, and I will let you do the other one with your calculator. If you don't have a calculator, you can go to Desmos, www.desmos.com. I think I already talked to you about it during the semester. Just to remind you, www.desmos.com, and you will be able to have a very nice graph of your function. So if I graph this function, I'm going to have, when you have y equal, I'm going to have a point right here, and you should have, if that is negative 1, I'm going to have something looking like something like this, and then going this way. Okay? And we have the range, which is negative infinity plus infinity, all real numbers, and the domain, and I can see that my range is read this way, when my domain is right here, and my domain, we said it is 1 plus infinity. Alright guys, so now we're good to go. You will have to look at your book. We will work this set of problem in class, and if you still have some difficulty, you will have to do the practice problem at home. Thank you very much, and talk to you in class.